Hello and welcome, this is Doug, WE6Z, and in this video I'm going to go over the build for my Fender Champ 5F1. It's based on the schematic from the Tweed Champ, or Fender Champ 5F1 from 1959. I built this one completely out of recycled parts, transformers I found, and an old signal generator for some television repair type of thing. And so it was a very fun adventure to build. So here we go. I was able to drill out the top of this aluminum piece to fit the transformer, and then I went to the Goodwill and I found this subwoofer box for $10 or $12, and it had an 8-inch subwoofer. I pulled the 8-inch subwoofer out and replaced it with an 8-inch Celestion guitar speaker. And there's the power transformer that I decided to use. It's a 700 volt center tap at 70 milliamps with 6.3 and 5 volts. Here's a general layout, tube sockets, switches, and the jewel indicator, and kind of a top view of that, trying to decide where to lay things out. Put the speaker out on the back of the box to keep it away from the power supply and some of the other things. So I did order up an eyelet board and wired that up, and that was easy. I mean, it was fairly easy, but it was my first time using the eyelet board, so it was a new experience. So getting ready to drill for the holes, and I got the holes drilled. I used a step drill bit. I got it at Harbor Freight for whatever it was, $9 or $10. And some of the holes were a little bit more difficult to drill, but it all turned out very well. And control placement, and there's the box drilled and all of the components installed, minus the tubes and output transformer. And looking at that, I wanted to do a complete custom look and a custom box, so here's what it looks like. And a little bit of the start of the wiring underneath, and I'm going to mount that eyelet board underneath as well. Starting out with filaments, the 5 volt filament there, and high voltage, and then the 6.3 volt filaments. Put the transformer output on top. Deciding where to mount the eyelet board, and then I had to use standoffs to bring it off of the board, so that it had space behind it. And there's the start of it. And starting to wire up some of the controls. I decided to put a rectifier, diode rectifier switch, so you can switch between diode rectification and tube rectification. In the end, it didn't seem to make too much of a difference except for the voltage, but it was still a cool feature that I wanted to add. I'll go through fairly quick on these pictures. They're progress pictures of the wiring on the inside. One note, I did use shielded, like an RG174 coax shielded cable for some of the audio signals going to the 12AX7, so they wouldn't get hum in them. Here it is with the front knobs installed. The jewel indicator, diode rectification switch, negative feedback pot, volume and power, and then the two inputs. Initially, firing it up, I measured different voltages. The voltage was a little bit high initially, but I did figure out how to address that later. Brought it up slowly on the Variac and did some testing with it. Here's an example schematic of the diode rectifier versus tube rectifier switch. So I found this one and copied that little section of it. I used some pieces and parts from this old diode analyzer, and I think specifically for the bias potentiometer. I had a fixed bias resistor in there, but 470 ohms turned out to be put way too much current through the 6v6 tube, so I ended up replacing that with a 2.5K 5-watt pot, so that I could adjust the bias depending on the input voltage or the B+ voltage. I also made a tube burn-in jig. These are all 6v6 tubes, so I ran the tubes at full filament voltage for 48 hours to make sure, and I found 3 tubes that failed after 48 hours. So these are old, used, original, new old stock tubes. Well, not new old stock, but old original tubes from different things. So found 3 that were bad, 3 that were good. And here it is. I don't have the volume knob on it yet, but testing, I got the 5Y3 rectifier in there and warmed it up, and it started working. Hooked it up to the oscilloscope and did some measuring. Hooked up an audio generator and put that into the microphone or the input jack to feed in an audio signal. Here it is, and I put some other labels on it as well. I turned it up and I was able to run it into a dummy load and get a sine wave out, which I was very excited. So we have amplification, and then a decent amount of breakup towards full volume, which is exactly what you want to see. I did swap out with a 5R4 WGA rectifier. Tested that for a little bit just to see if this one had less heat buildup, and it still got pretty darn hot, so I ended up going back to the 5Y3. Then I played some music from an iPod through it, showed that on the scope. That looked fairly good. And we'll go back real quick, and here's a quick video. This is showing putting the audio into it from the audio generator. This is into a dummy load. So there it is, my Fender Champ 5F1, home built, and learned a lot with this project. And next I'll have to test it out with an electric guitar.